Hello students, it's good to always come your way. I'm Divine Kweku. Today we are looking at mathematics, substrand algebraic expression. When we talk about algebraic expression, it is a branch of mathematics or an aspect of mathematics that deals with variables, numbers and operations. Now, these variables are usually letters of the alphabet mixed together with numbers, and then there are operations like addition, subtraction, division, and so on and so forth. Now, before we delve deep, we are going to look at some basic algebraic expressions and their meaning. Alright, now let's understand that when we say 7x, it means 7 times x, or the product of 7 and x. Also, when we say x plus y, it means the sum of x and y, or simply put, x plus y. Alright, now we can also have 4 into bracket x plus y. This also means that 4 times the sum of x and y. We can also have x minus y, which simply means x minus y, or subtract y from x, or take away y from x. Either ways, you can use it to explain x minus y. Now we can also have x out of y, which is also expressed as x divided by y. We can also have 2 out of x multiplied by 3. And then you can also explain it as 2/3 of x. Now, 1 out of 2k also means 1/2 of k, or half multiplied by k. We can have 10m minus 3, which also will go to mean that subtract 3 from 10 times m. M out of 4 plus 5 would also mean m divided by 4 plus 5, and then 1 out of 6n plus 7z would also mean 1/6 of n is divided to the product of 7 and z. Alright, so what we just saw are some bases that will introduce us to the expressions of algebra. Now, algebraic expressions can also be used to solve for perimeter of shapes. When we talk about a perimeter simply describes the distance around a 2-dimensional shape. So over here is a 2-dimensional shape. Alright? A 5-sided figure. And so we're going to find the perimeter of this shape. So simply, since perimeter deals with the distance around a 2-dimensional shape, we are going to add the distances uniformly. So this implies that alright, so we sampled and picked out all the respective figures, and then we are going to add it as we are doing it here. So we move a step further. Alright, so 8 plus 8 is giving us 16, and then k plus k plus k is also giving us 3k. Now you end here. You can't simplify it further because what is here, the variable that is here, is different from the variable that is there. And so you will need to try your hands on more examples going with this system and you'll be good to go. Alright, so we want to look at how we can also use algebraic expressions to calculate for area of shapes. Now this shape has a rectangle in the middle, and then it has a triangle on the left and another on the right. Okay, so how do we use algebraic expressions to calculate for the area? First of all, you must know the area of a rectangle. You must also know the area of a triangle. So I'm going to start with a triangle, and then I'll now work the rectangle. Let's see how it is done. So this is my formula for a triangle: half times base times height. Then I substitute the figures. Now, from the diagram, this side is given as K. And so this side is also the same as that side. And so my height is given as K. So I further simplify. 2 will divide 2. And then multiply numerator by K. Where A means the first one. I want to solve for B. B is a rectangle, so area is length times breadth, so I substitute. So when I substitute, I multiply. So 6 multiplied by K is 6K. That is what I'm getting here. Now I solve for C. C is also a triangle, so it works same for that, but let's work it. So half times B times H is also another form of writing the formula half times base times height. Alright, so I substitute the figures. The height is K. Now when you are done with this, you add A to B to C because the shape is together. Alright, so when you add them, you're going to have 8K. So when you see K standing alone, it means there is 1, but mathematically we don't write it. And so we assume there is 1 here plus 6, making it 7, plus another one, making it 8, and then you have your K. Alright, so we want to further look at simplifying algebraic expressions. Now, alright, so for us to simplify algebraic expressions, we first of all look at what we refer to as like terms. We want to group like terms. And so, in grouping like terms, you must ensure that each number here moves with a sign. So this is 9K. That is negative 5K. Positive 8L. positive 3k and negative 7L. When we are moving it, move it together with their operations. Alright, so now 9k minus 5k will give us 4k. 4k plus 3k will give us 7k. Now 8L, positive 8L minus 7L. So we're going to have 1L, but like I said earlier, we don't write the 1. So the final answer is going to be 7k plus 1. Alright, now in the second example, we are going to group like terms. Like I mentioned before, each here must move with its sign. Alright, now we're going to group like terms. Alright, so this is like terms. All variables with Q on one side, those with P on one side, and then those with PQ on another side. Alright, so we simplify. Here you must be conversant with your integers in order to help you do that. Now negative 12Q plus 15Q will give us 3Q. 6P minus 2P, 4P, and finally, now from here you can't simplify further, and so we end here. Alright, so do well to try your hands on several examples, and then whatever comments or questions you have, you can put it on the platform. Until then, see you later.